So, this week, OpenAI at their Dev Day released a really cool new feature called Real-Time API. And it allows to do a number of things, including prank calls, but it also opens up a whole realm of new startup and business opportunities. But I would argue that there's actually been a bigger breakthrough in the area over the past few months, and that's Kyotai Labs' Moshi. So I'm going to play you another clip, this time of Moshi, and they're going to be two voices, and they're both Moshi models speaking to one another. And I want you to pay attention to how natural it sounds, but also the low latency, so the low lag between one voice and the other.
One of my favorites is Perry Mason.
Ooh.
Yeah, it's an American legal drama series. It originally aired on CBS from 1957 to 1966.
So it was a TV series?
Yes, it was.
So didn't that feel really smooth? And you may have also noticed that at some point, one of the voices interrupts the other by saying yes on top of it, right? And that essentially is what's called back-channeling, and it's what humans tend to do to show that they're listening to the other person, but it also to show that they're supportive of what the other person is saying, right? And that adds to the natural feeling. Now, in contrast, let me show you another clip, this time of OpenAI, and pay attention to how big the latency is.
Oh, I've been so excited to talk to you.
That's awesome to hear.
So there's no doubt that just speaking about the voices, OpenAI's is way better, right? The Moshi one sounds a bit synthetic, but the lag between two voices makes it sound like a very laggy Zoom call or a long distance phone call back in the days. And that's because it's technically quite difficult to keep the latency low on a state-of-the-art model. Now, large language models are text-based, so they process text tokens and they predict text tokens. So OpenAI, when they're using advanced voice mode, they first have to translate the audio or oral signal into text, and they do that via automatic speech recognition, or ASR. They then get the model to predict an answer with the large language model, and then they have to turn that answer, which is in text token format, back into audio, and they do that via text-to-speech model. The advantage of this is that it taps into the huge amount of progress that has been made in LLMs, but the disadvantage is that you're adding quite a few steps, and this adds latency. As for the real-time API, well, OpenAI claim that it's smoother. Now, in practice, I think it is a bit smoother. I don't think it's quite as good as Moshi, and we'll come back to that in a second. But the question is, what are OpenAI doing differently for this particular model? And the short answer is we don't know. But we can tell some things from the press release. So it looks like they're moving away from this architecture of first turning into text with an ASR, then using a text-to-text model, and then outputting that via a text-to-speech model. Okay? And it also looks like they're using GPT-4o as a base for this. They mentioned that we're feeding in not just text tokens, but audio tokens to this model. Okay? But apart from that, we don't really know. However, we can look at what Moshi's been doing because their tech is open source. Moshi has what's called a unified multimodal model. And whereas a traditional LLM has one series of tokens that it's predicting constantly the next one, well, Moshi actually has three in parallel. So one for the user audio input, one for Moshi's audio output, and it also has an inner monologue, which I won't go into too much detail now, but it can be used for a number of things, such as fine-tuning the character of Moshi during the dialogue. Now, the audio input from the user and the audio output, they have two types of tokens. So it's a combination of acoustic, which represents the sounds, and semantic, which represents the meaning. And there's actually a second benefit to this architecture. So on top of the reduced latency, it also allows to process what's called non-verbal communication. So that's things like accents, emotions, and maybe one day, if they add cameras and visual tokens to this, they'll be able to process body language. And all this is extremely important in how we communicate.
If you were presented with McLaren F1.
So the first question that they tried to get an answer for was, well, how low does the latency need to be to sound natural? And so for this, they referred back to a study that was conducted around 15 years ago. So in this study, they found that on average, over the 10 languages, the latency was around 230 milliseconds, which is just under a quarter of a second. And English was pretty much around the same level at 236. The initial voice mode of ChatGPT, which is probably not state of the art, right, but it's a good reference for people, was around a few seconds. Okay, so quite slow. OpenAI's most recent advanced voice mode is probably between half a second and 1 second from what I can tell, right? There's no official stats on that. Looking at the videos from OpenAI's Dev Day, it seems like the real-time API that's just come out is around half a second, okay? And Moshi falls a little bit below 200 milliseconds, right? So below the average latency of the English language, and that's why it feels so natural. So this new generation of models that do not require to convert back and forth into text each time, they're actually bringing a step change, because we're going from a very robotic-like conversation with a second or plus of latency to a world where the latency is very close, if not below, the natural latency of human language. It allows interruptions, and at least for Moshi, it allows back-channeling. And on top of that, it can capture non-verbal communication, such as emotions or accents. And Moshi actually made a third breakthrough in the sense that you can run all this from your local laptop. So assuming you have a MacBook M3, which is probably not the case of everybody, but at least a few of you, well, you can have this conversation with the Moshi model without sending your data to the cloud. So there are obvious privacy benefits from that, but it also opens up a whole range of opportunities to bootstrapping startups who can play around with this kind of tech and develop new products without having to rely on expensive cloud-based GPUs. Okay, so the next question is, like, well, where does this tech offer the most opportunities? Now, the obvious one is voice assistants, okay, whether that be customer services, healthcare, and sales. Now, for me, there are a couple of hurdles that need to be overcome for that. The first one is making sure that it's functional, as in it does what it's supposed to do, right? So that's a combination of being able to diagnose, well, the problem, but also find the appropriate solution, or at least the next step. So for example, in the demo that OpenAI did for the real-time API, they essentially get an assistant to order a bunch of chocolates at a local store, right? If you think about it, you want these kind of assistants to consistently do what you need them to do in a shorter amount of time than it would take to do it yourself, right? So if you have to explain each time, oh no, don't order from X because I don't like there, or if you have to call up the store again to correct the order because you realize that they've done something wrong or they've paid too much, etc., then you're probably not going to use it again the next day, right? So this is just one example, but the functionality of it has to work. I mean, everybody hates robocalls nowadays, and everybody hates, well, at least I do, automatic answering machines where, like, when you call up the bank, for example, and you're trying to get into your account and it's checking things and it doesn't seem to understand what you're saying and it doesn't, I don't know, reroute you to the right person, etc. Right? So that's super frustrating to most people, at least. There's no doubt that this new generation of AI voice assistants is going to be much better than that. Right? But for me, there's also a question about how natural do we want them to sound? And for this, we can refer back to the uncanny valley principle, which says that the more realistic an AI is, the more we're going to like it, except in the uncanny valley. So there's a dip where it's almost too realistic to be true, and we're not very comfortable with that, right? And for me, the question is, well, where are we now with state-of-the-art voice assistants, and whether making the latency even smaller and adding things like back channeling, is that getting us out of the uncanny valley, or is it putting us in the uncanny valley where people will actually not like it because it's kind of too natural and it's kind of weird, right? For me, that's something that only time will tell. I think the second opportunity is in gaming, and this one, I would argue, is even closer to being ready to adoption, and that's in NPC voices. So for those who are not familiar, an NPC is a non-playing character. So it's somebody with whom you interact during a game that's played by the computer. Okay? And here I think the number one thing is making it sound natural. I think the second opportunity is in gaming. And this one, I would argue, is even closer to being ready to adoption. And that's in NPC voices. So for those who are not familiar, an NPC is a non-playing character. So it's somebody with whom you interact during a game that's played by the computer. Okay? And here I think the number one thing is making it sound natural.
But it could certainly be nominated for an award for commercials specifically about apples, like an Appley or something.
Yes.
Is there really an award called the Appley for Apple-related ad campaigns?
Yes.
Could we nominate me?
Yes.
Holy crap!
Okay, and the fact that they're creative is not necessarily an issue. Following instructions may be an issue depending on the type of game. So if it's an action game where you're having a bit of banter with the boss, for example, there I think following instructions is not so important. If you're in a role-playing game and you encounter an NPC who's supposed to help you find, I don't know, the next step in the quest, then there you want it to be functional and follow instructions to some degree. And the third area of opportunities that I see is in education. And in the OpenAI demo from Dev Day, there are some examples of companies they're already working with in the area of language tuition, for example, where the app corrects the pronunciation in Spanish of one of their users. And I think that kind of application will work in the not so far future, but I think it's more difficult and therefore not as ready as the first category. So compared to sales, customer services and healthcare, where you've got a voice assistant, I think there's a bit more of a longer term relationship in tuition or coaching, where the feedback you give depends on the feedback that you've provided in the past, and you want to consider the information you have about the existing level of the person you're coaching or tutoring. But I think there's a lot of fun stuff that you could do there around tuition and coaching, where you can actually interrupt the person that you're coaching to make sure that they do something correctly or pronounce it right.
Not quite my tempo.
And finally, there are a few other potential applications to this tech. Well, I mean, obviously there's going to be lots of people making prank calls and scamming others with that. And then there's the potential opportunity of using these voice assistants as interfaces. And on that one, I'm not so bullish. And I think here it depends on what kind of interface we're talking about, or what kind of application we're talking about, right? So if there's a need to be very precise, voice is not the best way to communicate. And this is one of the reasons why Elon Musk is working on Neuralink. It's because he's saying that the amount of information you convey by just talking to somebody is much lower than the information that you could convey just with a neural connection. And obviously, I mean, we're not there yet, right? But we will get there at some point. But I mean, in terms of audio interface today, like if you think about something like Siri or Amazon's equivalent, when do people use that? Well, I mean, there are always outliers, right? But I'd argue that the vast majority of uses are when you've got your hands full, and you're cooking and you want to know a recipe, for example. So you don't want to, you don't want to wash your hands to type on your laptop and Google like a recipe. It's just easier to just ask Siri or Alexa, and they'll find it for you. But I think if you've got your hands free and you've got your laptop in front of you, it's easier for you to just use your mouse and keyboard. And yes, we're used to communicating with other humans via voice, but it's not, as Musk points out, a very efficient way of communicating. So why would we want to use that sort of default way of communicating with AI assistants when there's probably a better way? Right, so that brings us to the end of this video. As you can probably tell, it was my first one, so I apologize for the lighting, for the sound and the editing, all of which were terrible. But hopefully it'll get better over time, and I have plenty of ideas in terms of other topics to cover. If you liked it, please subscribe, and see you soon.